Yeah, today we're very close to harvest here, but there's one thing we've got to do because we want to be able to figure out what went wrong and what went well. So we're going to count, weigh, calculate the components of yield. Now the components of yield are, and Lenny here is going to be my perfect assistant because she's doing this for like 10,000 samples each growing season. No person who can do this better than that. The components of yield are, okay, yield is basically the product of the number of particles per area. So let's say how many of these particles we've got on a square meter, okay? Yes. Multiplied by the number of filled grains in a particle, is that right?
Yes,
yeah?
yes,
Yeah.
Perfect.
And then multiplied by the weight of a grain. Now the weight of an individual grain is kind of hard to measure, so we usually count 1,000 or calculate 1,000 grain weight. So if you multiply these three things and you adjust it to a standard moisture content of 14%, that's usually how we express yield of a crop. And by quantifying, by measuring these different components of yield, and there's many other details to that, we can figure out then probably some reasons for why we have gotten a high yield or a low yield, and also how variable the whole thing was all over this field. Yeah. So I was gonna do this in a very simple way. So since we have a machine planted crop, so I thought, okay, I'm just gonna take like a stick, like a meter, and throw it somewhere randomly in the field. And wherever it lands, I would put it on the row, cut the rows and carry them out.
But
is that a good idea?
No, that's not what we do.
Why?
We have to be more scientific. So what I suggest is, like, I know the size of this plot. It's 12 meters by 100 meters. So from that size, we try to use the Excel function to generate numbers.
Random numbers.
Random numbers. Yeah. So
why do you do that? I mean, I know I can pick a spot here and there, and you wouldn't trust me to pick the right spot.
We want to avoid bias.
Bias.
Yeah. Or like we need to get locations that are representative of the whole area. And using 8 different locations by these generated numbers, I think that would capture the variability and to get a
Okay, that's what we're gonna do. So we'll use random locations, and then we'll show you in a minute what we do at each place.
Okay.
Here is one of our random number generated locations. It says 54 meters from the end of the field, 5 rows in. All right, let's go and find it. Where is it? Yeah.
So we need to count now. 1, 2, 3, 4, 5. So we start here.
And what we're gonna do here, when we are here?
So we have to have our measuring device now.
A measuring device. Okay, where is the measuring device, guys?
Yeah.
Okay, good.
Be careful. Yeah.
Aha. So we've got a tape here. So they are putting the tape where?
Here. We have to start from here, Rene.
Yeah. Right between 2 plants, right?
Yes,
so that we don't bias the sampling.
Yes.
Yeah?
And then
we got to make sure that the tape is nice and straight on the surface.
Yes, and then we count the number of plants from here.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
And then we read
The distance.
the length?
What is the length? 1 meter 90.
1 meter 90 again?
No, wait. I think you got 11 plants. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This one is the cutter.
Oh, very nice.
Yes.
1.9.
1 meter 90 length.
Okay.
10 plants. Okay.
So we need to write down now in our data sheet.
Yeah.
1.9.
Let's cut them.
So now what we are doing is to detach the panicle individually.
Okay, we got to carry those out and then we'll process them.
Okay.
Okay, good.
Yeah. Is it the last one now, Rene?
Okay, I'll take this. Okay. You got them 10?
Okay.
Yeah. But what I've noticed, I don't see too many whiteheads, so stem borer damage seems to be low this time. I don't see too many disease problems. Would you agree?
Yes, I haven't seen anyone actually.
Good, that's reason for hope. So what do we see?
We see different number of tillers. like ranging from how many?
10 or less. Less
Yes.
than 10 in some cases. That's
Yes,
bad.
and more than 20.
And more than
maybe
20 like in
25.
this one here.
Yeah.
But not all of them will have a panicle, right?
Yes.
So are we going to count all that stuff?
We're going to count, first we're going to count the number of tillers and then the number of panicle. That way, we will be able to know the tillering efficiency.
Tillering efficiency.
That will be the ratio of the panicle and the total number of tillers.
What else are we going to measure on this?
We will detach the panicle, so we will partition the organs. We will get the panicle dry weight, blade dry weight, and the stem dry weight.
Right.
Then we will get the total biomass, and then later on we will separate the field and unfilled grains. So the ratio of the field grains to the total biomass will be our harvest index.
That's a lot of work, but very, very useful data that we'll make use of. Let's get going. Can't wait for these data to come in.
They will soon come. We just need to put them in the oven for 72 hours at 70 degrees centigrade. All of this, we will have partitioned biomass, and then later you will soon have the data.
Good. So this is the hybrid today. The inbred, we have to do the same kind of sampling in about 5-6 days because it's behind in development. And then we'll come back also in 5 or 6 days to do the final harvest of that hybrid already.
Yeah,
Thanks.
so we will come back for the inbred. We now bring our samples here in the lab to do detailed measurements. We have to look for plant traits that would relate to yield, so that's why we are doing all these measurements. First, we have to be very careful not to lose any dead material. So first, we have to remove all the dead materials, and then afterwards, we need to go to the washing room, remove the soil, and then bring back again the samples in the lab and carefully remove the roots. And we also have to have the data sheet where we will be putting the date, because we need to count the tillers. The tiller number, we have to put it in our data sheet, and then later on we also need to count the panicle number. We need to determine the tillering efficiency at harvest, so that's why we are counting the tillers. This includes all productive and non-productive tillers. And then afterwards, we will do now our partitioning of the organs. First is we need to remove the green blades, and then afterwards remove the dead blades and then the stem, and we put them in their corresponding bags. So after separation, we need to put these samples in the oven at 72 degrees centigrade, and we put these samples for 3 days. And afterwards, we will be measuring and collecting the dry weights. After counting the tillers, we also need to count the panicle number. Since we sampled 10 plants, so we are counting the panicle number of the 10 plants. We will then just get the average panicle number per plant later on. So after separating the panicles, the green leaves, the stem, we are now ready to put them in the oven, set at 70 degrees centigrade. And we will wait for 3 days before we take them out and collect the dry weight using analytical balance. From the oven, we bring out the samples and wait until the temperature equilibrates to room temperature, and then we will then put the samples on this one and collect the dry weight.